In this video, we'll look at operations with vectors component-wise. That is, beyond just the visual representation of vectors as some arrows, but we'll look at the numbers behind these. So let's say we have some vector u, and that has the components -3, 2. Now we will look at this visually. We'll see what this looks like. It looks just like that, as an arrow. And let's say we also have this vector v, and that has the components, let's say 4, 2. And that would put it right about here. Now, let's say we wanted to add these two, vector u plus vector v. What would be the resulting vector? Well, graphically, of course, we could just show that, draw this red vector. Now, component-wise, or algebraically, we can look at it like this. We will add the -3 and the 4, these first components, -3 plus 4, and then we'll add the second components, 2 plus 2, 2 plus 2. So the u plus v then becomes 1, 4. So those are the components of the vector. And sure, we could draw that resulting vector, u plus v. Now, there are a lot of other things that you can do component-wise. That's just one, just adding those. What if we wanted to subtract u minus v? Well, it makes sense. You would probably figure out what we would do. We would do the u, -3 minus 4, and then 2 minus 2. We would just subtract those directly in the order that it's given to us, u first and then v. So u minus v would have this -7, 0 components. Okay, let's look at some other ones. Let's take a look at scalar multiplication of vectors. What if we wanted 2 times u? Well, we know that graphically that is simply the u vector in the same direction but twice as long, twice the magnitude. Component-wise, it is 2 times the -3 component and 2 times the 2 component, referring again to these components. So 2u then has the components -6, 4. All right, and we could go 1/2 as well. Let's take a look at that. Let's take a look at 1/2 v. 1/2 v. Okay, that equals 1/2 of the 4 component and 1/2 of the 2, and so 1/2 v equals component 2, 1. Okay, so we've got some of that. Now let's put it all together. What if we wanted to figure out what is 2u minus 1/2 v? 2u minus 1/2 v. Well, let's just take what we have here. This is the 2u, and this is the 1/2 v, but we want minus, so I'm going to go -6 minus the 2, because it's minus 1/2 v, so minus 2, and the other component is 4 minus the 1/2 v, the component there is 1. So the 2u minus 1/2 v, I'll write it up here, equals the components -8, 3. So not a difficult process for doing the operations with vectors component-wise, but it's certainly necessary to understand how these numbers stack up and multiply to work together to perform the operations with the vectors component-wise.